Okay, so this lesson is about trigonometry and using the trigonometric ratios. Okay, so we're going to look at using the trigonometric identities to find lengths of a right triangle. That is a triangle that has a one angle being 90 degrees, and using also the trigonometric identities to find angles in a right triangle when you are given a couple of lengths. A couple of things that it is assumed that you know to be able to understand this lesson is that you've been introduced already to trigonometric ratios, that you have been introduced and understand Pythagoras and the Pythagoras theorem, and you have some capacity to rearrange equations. Okay, so just a review of what SOHCAHTOA is. So that is an acronym that we use to help remember the trigonometric identities. So for so that is sine of theta equals opposites over hypotenuse. This one is that cos of theta equals opposites over hypotenuse, and the last one is tan of theta equals O over A. Sorry, this should be not O over H for cos theta, that's A over H. So that one is A over H. Okay, so let's start with the first example. Okay, so given the following right angle triangle, we need to find the two unknowns, which in this particular case is x and y. So the first thing we need to do is to label the triangle in terms of opposite, adjacent, and the hypotenuse. So we look at the hypotenuse is always, and my apologies, this should have a right angle in here, the hypotenuse is always the longest side. So in this particular case, it's this one here, because that's the longest side. So the opposite one is always opposite the angle that's given, or the angle at which you would like to use the identities for. So the opposite side to this one is, oops, I didn't mean to do that, is opposite here. Directly opposite is our O, and then adjacent to the angle is then the last one. Okay, so that's the first thing to do. So now we need to figure out which sides we need to use, and therefore which of the three identities, trigonometric identities, we should use. So we have H, and at first I want to find x, right? I'll do this one first. So I want to find x, and I already have h, so that's an O and a h. So for SOHCAHTOA, I'm going to then use sine of theta equals O over h. So that's the formula that I'm going to use, and now I'm just going to substitute the information that I've got. So I've got sine, and my theta is 36 degrees, equals my opposite is x, that's the unknown, and the hypotenuse is 9.8 centimeters. So just leave it at 9.8 for now. Okay, so at this point we need to rearrange the equation a little bit. So we want x by itself, and at the moment it's getting divided by 9.8. So I'm going to times 9.8 to both sides, and then they will cancel out, and that gives me just the value of x. So x equals 9.8 times sine of 36 degrees. Okay, and I put that into my calculator to get the answer. So I'll just bring in the calculator here. Here's a calculator. Okay, and I'll just get it out of the way so I can see what I'm doing. Cool. Alright, menu, run. Alright, so I want 9.8 times sine of 36 degrees. Okay, oh, and I get a negative number, all right? So this is telling me that my calculator is probably set to radians. So I'm just going to change that, check that, and it is angle is radians, so I'm just going to put that in degrees and try this again. 9.8 times sine 36. Okay, and I get 5.76. So I'm going to do it to one decimal place because my data is only with two significant figures, so 5.8. So it equals 5.8, and it's centimeters. Centimeters. Okay, and that's my length of x. All right, so now I need to find a length for y. Okay, so now that we've found the value of x, we can find the value of y. In fact, we didn't need to find the value of x first, but now finding y, we can use the value of x and use Pythagoras to find y, but if I made a mistake with this one, then I'll definitely get y, the value of y, wrong as well. So I'm going to avoid doing that and use the trigonometric identities again to find what the value of y is. So what we need to do now is to determine what trigonometric identity to use. Okay, so if I just change the color, okay, so again we've got our opposite, and now what we want to use is our adjacent. Okay, so we want to use the adjacent side, this one, and again the hypotenuse, and so the identity including adjacent and hypotenuse is the cosine identity. Okay, so we end up with cosine of theta equals our a over h, and we put in the values that we've got, so we know cosine of 36 equals our a, which is y, over h being 9.8. Again, we times both sides by 9.8. They cancel out, and we end up with y equals 9.8 times cosine of 36. We put that in on our calculator. So I get 9.8 times cosine of 36 degrees. Okay, and I end up with two significant figures is 7.9 equals 7.9, and our units are in centimeters. Okay, let's look at another example. Okay, given the following right triangle, find A and B. Okay, so again, we need to label this triangle in terms of which side is opposite, adjacent, and hypotenuse. Okay, so hypotenuse is the longest side, and that's this one. And the opposite side, so it's opposite to the angle other than 90 degrees that we're given, which is A, and the adjacent is the one adjacent to the angle. Okay, so first of all, I'm going to find A. Okay, so what trigonometric identity do I need to use to find A? Well, I have O and I have A, or I want to find O and I have A, so I need to use tangent. So tan of 52 degrees equals O, which is our little a, over 5.6 meters. Again, we times both sides by 5.6. They cancel out. I'm left with A equals 5.6 times tan of 52. And that's when I put it on my calculator. I've got 5.6 tan of 52. And you can see here I've left the times out between 5.6 and tan. That's because the calculator knows that it's multiplication. And when we're multiplying a number with any pronumeral or function, we don't need to put the multiplication sign in there. So this one is 7.2 to one decimal place, or to two significant figures. 7.2, and now I'm in meters. Okay, and that's the value of A. So now let's find the value of B. Okay, so again, this was our O, this was our A, and now this has moved. This should be here, and this is our A. Okay, so now I'm not going to use the value of A, which I just found to be 7.2 meters. I'm not going to use that though, because again, if I've got that wrong, I'm definitely going to get B wrong. So I'm going to use trigonometric identity now to find what B is. So I have A, and I want H. So I'm going to this time use the cosine. So I have cos of 52 equals our A, which is 5.6. Sorry, it's a bit confusing because there should be 5.6 here. 5.6 over our H, which is B. And now we can see that our unknown is on the denominator. So we can't just simply times both sides by the denominator, and that's it. There is a couple of steps that we need to do. So just looking at those steps. So first of all, I don't want this fraction here, so I am going to divide both sides by B. What I'm left with is B times cos of 52 equals 5.6. But now I want B on its own, and at the moment it's getting times by cos of 52. So I'm going to divide by cos of 52, and what I do to one side I have to do to the other side, so I'm going to divide this by cos of 52. These cancel out, so I get B on its own, so I have B equals 5.6 divided by cos of 52. And now I put that on my calculator, so I have 5.6 divided by cos of 52. And I get 9.1 to two significant figures. Equals 9.1 meters. And that makes sense because it's the hypotenuse and it needs to be the longest side. And at the moment it is the longest side because it's 9.1. The other one is 7.2 and the other one's 5.6. So I can trust that answer because it does look right. Okay, so now that you know how to rearrange that equation, there is a bit of a trick. And so I'm just going to rub out this page and show you that trick. Okay, so when we're at this point, okay, and you can see that your unknown now is on the denominator, what you can do is you can do a bit of a swapperoo of these two. So you just completely swap them over. So you get B equals 5.6 divided by cos of 52. Okay, so whenever you see the scenario where you have an unknown on the denominator in a trigonometric equation, you can then swap that with the other side of the equation, and that avoids you needing to go through and rearranging the equations every time. That's assuming you know how to rearrange them though, in case it does present itself a little bit different. But it's a quick way of just swapping them over. And I will continue on now finding angles in part 2.